With this video, I'm going to talk about what happens during contraction to a sarcomere and what happens to the different bands and zones. But in order to understand this, we need to remember what goes on or what makes up a sarcomere. And so if you recall from our previous discussions, a sarcomere goes from one Z line to another Z line. So here is our Z line, here is our Z line. Now in the middle, we have the M line. Okay. Now attached to the M line is the myosin fibers, okay? So we're gonna have a couple sets of myosin fibers here. Okay, we'll just do two, actually we'll do three, all right? And then attached to the Z lines is the actin, okay? And so we've got actin here, all right? And so these lines are actin, and then this is our myosin, okay? Now, when it comes to a sarcomere, we can classify it a few different ways or a few different areas of it. So the first thing that we can do is we can define what's called the A band. Okay, and so the A band just goes wherever we have myosin. Okay, and it's called the A band. A stands for anisotropic. All right, and so wherever we've got myosin, light can't get through it, so it looks dark in a micrograph. And so as a result, that's why we call it anisotropic. All right, so wherever there's myosin, that's the A band. So next we've got what's called the H zone. And the H zone is where we only have myosin. Okay, so you notice from about here to about here with all of these myosin fibers, if I drew it correctly, there's no overlap with actin. And so that's your H zone. And then finally, I'll draw it down here, we've got what's called your I band or your I zone, okay? And the I zone is very similar to the H zone in that it's the place where we only have actin. Okay, it's called the I zone, or the I band, excuse me, because it's isotropic. Or in other words, light can get through this. And so when you look at this through a micrograph, it's very light, especially compared to the A band. So what happens to a sarcomere as we go through muscle contraction? Well, if you recall, none of these fibers get shortened. However, what changes is the amount of overlap. So I'm going to draw this out again. So here's my M line, and we're going to have our myosin fibers here. Okay. But what happens now is that we've got a lot more overlap. Okay. So there's my actin lines again. And so on the ends, we've got the Z lines. So Z and Z. And then we've got M in the middle. Okay, so if you look at this, I went too low. If you look at this, what's happened is our A band stays the same length. So here's the A, but our H zone has gotten much smaller. So this is H right here. And then if you just look at it, we're just gonna do it down here. This is my I band right here because we have so much or so little overlap. And so as a result, when we contract, when we have a muscle contraction, the sarcomere, the H band or the H zone and the I band get shorter, but the A band stays the same length. And it's important to remember that whenever this muscle contraction is occurring, that the actin and the myosin fibers are staying the same length. The only thing that's changing is how much overlap we've got. So in a relaxed state, there's less overlap, and so the A band and the H zone are bigger, or excuse me, the I band and the H zone are bigger. But when we have muscle contraction, there's more overlap, so that H zone and the I band gets smaller. And so this is the basics, and hopefully something that will help you understand how a sarcomere changes during contraction.